Greetings, Earthlings! Today we're going to take a look at the TEKPOWER TP7244L Analogue Multimeter. I just got this, and so this is not going to be a true unboxing. I have, in fact, opened the package previously, but that's what the box looks like. And you open it up, and oh, that's not it. There it is. That's the meter. It has DC volts from 0.1 full scale to 500 full scale. AC volts 10 to 500 volts. Resistance 1 ohm full scale. Ha.
We interrupt this program to deprogram your digital-minded dweebery. This isn't like a digital meter where there's an upper bound on each scale. On an analog meter, the scale runs from 0 ohms to infinity, regardless of the setting. But it gets pretty crowded at the high end of the scale, so you select a multiplier, in this case, ×1 to ×10,000. And that helps to get the reading in the right half of the scale where the resolution is better. We now return to your regularly scheduled program already in progress. Please proceed, Governor.
And current, 2.5 milliamps, full scale. No, I'm sorry, 50 microamps. This is a 50 microamp meter here. So that's 50 microamp scale on up to 10. Well, it's got a 10 scale. We're not even going to look at that. It has on the back, as you can see, what do you call that? Support. So you can set it up, and that looks nice. Comes with probes. These are the probes. Now, with little those will get lost. With little caps on them. I don't know what those are for. Golly. That goes in there. That goes in there. And the probes, those will get lost too. Look at that. They've got little end pieces on there. So, no clips, just straight probes, and a so-called instruction manual. Yeah, user's manual. Okay. Which says a little, but not a lot. Okay, so basic accuracy on this thing. On DC volts, it says ±3% full range. AC volts, ±4% full scale, full range. DC current, ±3%. And resistance, ±3% of arc. Because, of course, full scale is 0 ohms on this. So, well, let's start with resistance. Let's play with this. Now, I have here a reference meter that we're going to use that we can pretty much trust. Although, oh, look, those probes look very, similar. This can do 4-wire resistance measurements, but I'm using 2-wire. So there's the resistance of the leads. That was interesting. Approximate resistance of the. That got worse. I said the resistance of the leads. Okay, it's going to be small enough. And here, I'm going to go to the 1K scale. The way these analog meters work is you initialize it to 0. Oh, let's look at something here on this meter. You see this? See this shiny bar here? Now, real meters. Well, I say real, but you can see up here. I have an HP. That is not a cheap meter. It doesn't have one of those shiny bars. What it does have is a sort of knife-edged pointer. But what that's supposed to be reflective. I mean, actually like a mirror, so that you line up the reflection of the pointer with the pointer. You know, you move your head around till there's no reflection, and then you know you're reading it properly. There's no error in reading. But because this isn't polished, I guess it's aluminium, depending on how advanced the country is that you're living in. The more advanced countries, they call it aluminium, I suppose. In America, they call it aluminum. The I got lost somewhere coming across the pond. It's worthless, but it makes the meter look perhaps a bit more expensive, or high end than it actually is. This costs about $30, by the way. This one, I don't know. Got it on eBay, I think, sometime back ago. Okay, what I have here, let's see if I can get that. Oh, that's pretty good. I get them both in there. We're not going to get close-ups of the screen, so you're going to have to trust what I tell you. I got crud here. Okay, yeah. This guy right here. 10K, 0.1% resistor, okay? And what I'm going to do is I'm going to put the Tektronix meter on it and verify that. Now, this has been sitting warmed up for a couple of hours now. Oh, come on, you can do better than that. Let's see. So if it's 10K, then 1K would be 10%. Oops. 0.1K will be 1%. 0.01K would be 0.1%. 0.001K, yeah, so it's within 0.1%. That's pretty darn close, actually. Let's see how this does. Okay, I zeroed it out, all right? And I'm going to put that on there. Oops. All right, I'm going to put this here. Okay. And I don't know if you can see that. It is reading 11K. Let's see if I can bring that up, if it'll focus in on that. I don't know if you can see that. It's reading 11K. Meh. I'm not impressed so far. Okay. Actually, for real world practical situations, that's pretty close. You're not going to use this where you need high precision. Okay. Let's try DC volts. Switch this over to DC volts. Here I have, I don't know if you can see that. Can you see that? Can you see that there? That's an HP 6205B power supply. Okay. And it's currently set outputting about 5 volts. Let's see how close I can get it. Of course, it may drift because I just turned it on, but oh, that's pretty close. 5 volts. Okay. So now, oh, you know what I want to do? I want to take these. I'm going to just sort of parallel things up here. We're not worried about the resistance of these little clip leads or anything like that. Well, being an analog meter and not a a VTV, no vacuum tube or FET front end on it. It's because of 50 microamp movement, it's 20,000 ohms per volt. So at 5 volts, I'm presenting a load of 100,000 ohms.
The correct answer is 200,000 ohms because the meter is set to read 10 volts full scale. 10 volts through 200,000 ohms gives a current of 50 microamps, which causes the meter to deflect to full scale. Put 5 volts on it and the current will be 25 microamps, causing the meter to deflect halfway. That's the way it works.
Which should not affect the reading significantly. So if I take this off, put it on, you're going to see on the Tektronix meter it doesn't change. Okay, it's high enough impedance. Okay, so DC volts are on this scale here. There's 250 or 25 full scale, 50 or 5, 10 or 100 full scale. We're on 10 volts full scale. So, and we read off of this scale, this is for AC volts, this red one down here, and we'll get to that. And that would be 5 volts right there. So it's reading about 4.9, which is within its rated accuracy, I suppose. Let me crank the voltage up. I can go to, what if I go to 10 volts? I said 10 volts. That's pretty close. And it's reading it's reading just above 10 volts here. So that's, again, not horrible. I'm going to try 9. You know, it'd be good enough to tell you if your battery's dead or not. Again, you're not looking for absolute precision. 9, you know, again, it's just above the 9 volt mark there, so pretty darn close. Good enough. Yeah. Okay. It also measures current. So let's take our 9 volts, and let's run our 9 volts through this 10K precision resistor. How about that? Power supply out is right here. That goes to one side of the resistor. Now I have to connect these in series with each other, don't I? Okay. Let's see. I'm going to switch this. Okay, so 9 volts. There should be about a milliamp, right? So I'm going to go to the 2.5 milliamp scale. It's going to be less than a milliamp, but, you know, roughly a milliamp. Okay. Then it comes from the power supply through the resistor, through this meter, comes out of this meter, and goes into, let's go DC current, and I have to switch this here. DC current, okay, and then into that meter. Okay. Well, there you go. 878 microamps. Yeah, 0.878 milliamps, okay? Okay. This is on 2.5, so I've got, this is reading 0.7. Let me bring it up to 1 milliamp. Okay, that, whoops, I was there. This is old equipment, is it not? Yes. Yes, it is. It's very old. So perhaps a little flaky. Ah, that's close enough. So that's reading 1 milliamp on the meter I trust. This is reading, you know, about 0.95 milliamps. So again, pretty close. Close enough for government work. Okay. Now, let's try AC volts. For that, we're going to have to switch to a different device. Thank you very much, HP power supply. Okay, you see these leads right here? They're coming from an HP 3310B function generator, which is set on sine wave. We're not going to need you anymore. Thank you very much. AC volts. Put that back up. Yeah. Put that back up there. Okay. And I've got it set to about 100 hertz. There you go, 6 volts. This will measure frequency as well. It's an analog device, so okay. So there you go, 103.37. Not that that really matters terribly much. Okay. Oops, AC volts. We're on a 10 volt scale here. Okay, oh, you know what else I have? I have this HP 334A Distortion Analyzer, which is also an analog meter. And it has a voltmeter built into it. So I can measure that as well. We'll just get another reference point for no good reason. There we go. Okay. Wow, Tektronix says 6 volts on the nose. This guy, now we're reading the red scale. And again, it's just below 6, you know, like 5.9. We'll bring that up there. Maybe you can see that. About 5.9. The HP also reads about 5.9. That's interesting. Analog and digital disagree. Well, maybe I should trust the analog meters. Maybe it's spot on. I doubt it. Okay, so that was 6 volts. I can bring that up. Let's try 8 volts. This has a less precise control than the DC meter does, but I can get it pretty darn close to 8 volts. Up here, 7.85, 7.8 something. Here, spot on 8 volts. Very nice. Very nice. Okay, what this doesn't specify anywhere in this manual is the frequency range for AC voltage measurement. The HP Distortion Analyzer is good on this range, is good to 1 megahertz, plus or minus 2% to 1 megahertz. That's pretty good. The Tektronix is good, I think, to 100 kilohertz. Okay, we're at 100 hertz. Let me crank it up. Let's see. Go to 1K, 1 kilohertz. Tektronix still says 8 volts. HP says 7.9-ish, you know. This still says 8 volts. Spot on. Very good. Let's go to 10K. Okay, Tektronix still says 8 volts. The HP is getting closer to reading 8 volts. This has dropped now. Okay. This has dropped to like 7.5 volts. So now we're going to try and find out where does it start to drop off. We know it's between 1K and 10K. So there's 1K. I'm doing the rotary dial now, which runs from 1 to 50. So I'm on range of 1K, and then, well, look. We know the output voltage doesn't change, really. Okay. So we're at 960, and we'll watch when this starts to drop. I don't know, am I in the way? I can't tell, because I'm leaning over here. I'm looking back up over here. No, I'm fine. Okay. There it's dropping. Okay. So somewhere in, well, let's see. Yeah. You know, if you want to minus 3 dB, that might be an official reading. I'm going to say 5K is the useful bandwidth, because as we go any higher, it dies. Okay, we can say AC voltage up to about 5K. How low does it go? Oh, you really want to know that? Golly. Oh yeah. Yeah, that's 10. You can see that dropped off a little bit. It's below the measuring capabilities. Okay. This guy goes down to about 20. Okay. There, we're at like 18 hertz. Still very close to 8 volts there. That one showing 7.8. This one bouncing around, but still very close to spot on 8 volts. So I'm going to say it's good to from 20 hertz to 5K. Does appear to meet its specifications accuracy-wise. Only costs $30. For what you pay for it, seems like a decent bit of kit. But you have to have good fingernails to get this support open. It's got some sort of like silicone or nylon or whatever that is, plastic protective case over it. I would not try dropping it to see how to see how rugged that is. This is not a ruggedized device. But again, pretty decent for $30. And everyone should have an analog meter like that. No. VOM, they used to call them, volt ohm meter. Or volt ohm milliamp meter. VOM meter. Yeah, not high on accuracy, but good for watching. You can spot things like drift and trends and nulling things out and peaking them is easier with an analog meter. So it's a good thing to have. But again, when you're if you're looking for drift, or you're looking or you're peaking something or nulling something, you're not concerned with absolute accuracy of the reading, because you're just watching the needle movement. And in the case of drift, if the needle moves, then yeah, it drifted. In the case of nulling, you're seeing the needle change direction, nulling or peaking. It'll change direction. So, fun little bit of kit. That's it.